not like that. I can call any of the group anytime. And so, guys, stay on the call, be prepared. And whenever I ask you, I call out your name or your group name, you have to come out and just present your project. Fine. And for the team members, I want to confirm, like all of the team members who have presented, like who have contributed in the project, they have to be present in the project. Like if they have to be present here in the meeting, discussing about the project when the your presentation is going on. Fine. And next, after the presentation, you have to show me your mails that you have shared all your mini projects during the tenure of this internship. You have mailed them in the shared mail ID. You have to show me that. Fine. Hope everything is clear to you. Guys, is it clear?
Yes, ma'am.
Fine. Great. So we'll first start with group one. So group one, Aditya Patil, Anushka Bhatia, and Pankaj, they were not responding on the day we have a project review session. Kevin Gandhi and Harsh Mishra, they both decided to work for like because others were not responding. So guys, are you present here? Group one, Kevin Gandhi, Harsh Mishra, anyone? If present, Harsh Mishra, I can see you. Can you just unmute yourself and can give me the details? Guys, am I audible?
Yes, ma'am.
Okay, fine. Uh, okay, let's just move ahead to group two. Bhavani, Gitanjali, Pavan, K. Rohit, and Kavya. Guys, everyone available here? Just raise your hand, guys. Group two people. Just raise your hands. Okay, two I can see. Rest three. Okay, four. Fifth one. Bhavani, she is not here. Okay, five. Fine, great. So, Gitanjali, you're the group captain. So, can you just unmute yourself?
Yes, ma'am.
So, guys, you're ready for the presentation?
Yes, ma'am.
Fine. So, I'll just ask you to go ahead with the presentation. Okay. So, just allow me a minute time. I need to check with the other group. After I'm done, then you will just go ahead with the presentation. Okay. By the time you can just discuss among yourself who will go first or next. You can just coordinate among yourself. Just allow me some time. By the time, I'll just check with the other group members. Okay.
Okay, ma'am.
Yeah. Guys, group two people, just raise down your hands. So we'll just call off for group three. Laksh Jain, Svetanshini, Shivani Sadani, Prashant, and Hana Fatima. Guys, raise your hands. Okay. Okay. Svetanshini, you're here.
Yes, ma'am.
Okay. So you have been telling that Laksh didn't take care about the details, like the Tableau part of the project, right? So other
Ma'am, he
things
was
are,
uh, Ma'am,
yeah,
he was
tell.
supposed to do the Tableau part, and he informed us today, 3 to 4 hours
Hmm.
before, that he will not be able to present. And we asked him to, if he would have told us before, we would have done it ourselves. But he is not replying, and he just sent us a file, and that is not working at all.
Okay, so the Tableau part is not ready, right?
Yes, ma'am. Ma'am, the rest of everything is done, but the Tableau part is not ready.
Okay, fine. So, if we give you time till tomorrow, will you be able to prepare your Tableau part?
Ma'am, actually, I am not good with the Tableau thing, and that is why I could not prepare it.
So you have other
I've done
team
the graduation
members,
part.
right? Prashant is there, Shivani is there, Hana Fatima is there. So just I'll just check out with the other team members. You just go ahead, have a discussion among yourself. Like, will you be able to prepare your project, like the last part, that is the Tableau part, by tomorrow? Will it be possible? Just have a discussion and inform me. Fine, I'll just come back to you. Okay, Swatanshini?
Yes, ma'am. Okay.
Okay, just have a discussion in your WhatsApp group and confirm me. I'll just come back to you. Okay, so group three guys, just raise down your hands. Okay, we'll go by group four. Abhijay, Sneha, Sudarshanan, Jhansi, and Shivani Sambarkar. Guys, raise your hands. Okay. Abhijay, you're here.
Yes, ma'am.
So you, all of your team members are here, is it? I
Yes, ma'am.
guess
But except Janvi, Jhansi, ma'am.
she just joined in. I guess I have just admitted her.
Yes,
I
ma'am.
guess she has joined in. Yes. So everyone is available, right, from group four, Abhijay?
Yes, ma'am.
And everyone has put it in efforts in the like the project that you have prepared.
Yes, ma'am.
Okay, so your project is ready, right?
Yes, ma'am.
Okay, fine. So after group two, you will be presenting today. Fine.
Okay, ma'am.
Okay, so have a discussion among yourself who will go how, and like it should be ordered like right, who wants to go first, then who among your team members, have a proper discussion, then we'll just come back after the presentation of the group two. Fine.
Okay, ma'am. Ma'am, I had something to say.
Yeah.
Ma'am, actually, I haven't mailed them my mini projects yet, ma'am. On the mail
Okay,
and on
you,
the Google form
I
as well.
got it. You have time right now. You can do it now. That is mandatory that you have to do it and you have to show me. So you can, you, those who have not done it, you still have time. So you can do it now.
Okay, ma'am.
Okay? Yeah. So group five, Anjali, Priyal, Soham, Simran, here in the meeting. Anyone? Okay. Sneha and Prashant, you can raise down your hands. Jhansi also raise down your hands. Group six, Aditya, Bindu, Abdullah, Sri Vara Prasad. Anyone available? Okay, fine. We'll just move ahead to group seven. Himanshu, Mayank, Varinder Singh, Ravi Oja, Deepak. Available? Guys, if you are here, just okay, fine. Deepak, I can see you. Okay, fine. Deepak, Himanshu, Mayank, Varinder. Okay, Ravi is not here, right? Himanshu, can you just unmute yourself?
Yes, ma'am.
Yeah,
Actually,
Himanshu,
Ravi is
just
out of station, so he's facing a
okay.
network issue. That's why he's not present.
Okay, so all of your team members has put it in efforts in the project that has been allocated.
Yes, ma'am.
So
Very
your
much.
project is ready.
Yes, ma'am. Already.
Great. So after group four, you will be presenting. Okay, Himanshu.
Okay, ma'am.
Okay, fine. So Priyadarshini, you are here. Priyadarshini, you are here. Okay, guys. Fine. We'll just move ahead. So, guys, you can just raise down your hands. Before that, I just want to ask group three. Swetanshini, you're here.
Yes, ma'am.
So, Svetanjani, is it possible for you people to just prepare the Tableau part of your project by tomorrow?
Ma'am, is it possible that we present up till what we have done? We have done, each of us have done our work.
I understand, but see, the project was still the Tableau part, but the Tableau part is not prepared till now, right? So that's what I am asking. Like, will it be possible for you team members working together to prepare the dashboard part in Tableau? Like, we'll
Ma'am, we
give you
can
time,
try
but
by tomorrow.
okay, fine. Okay, fine. So you can just change it to Power BI if you are able to do it in Power BI, the dashboard part, if you're comfortable in that.
Okay, ma'am, we'll discuss and do that.
Okay, you just discuss among yourself, and after the group two presentation, I'll just ask you, like, come back to you again. You just confirm me with the details. Like, how is it possible? Will you be able to do it or not? Fine?
Okay, ma'am. Okay.
Okay, fine. So, group two, you're here, right? So, guys, you can start off with your presentation. Gitanjali, you're here, right? Group two.
Yes, ma'am. Pavan is
Okay,
starting.
then,
Just wait, please.
Hello, ma'am.
sure.
I'm Pawan.
Yeah,
Can I share my screen?
yeah, sure.
Ma'am, is it visible?
No, not yet. No, I can't see your screen.
Ma'am, you know?
No, not yet.
Ma'am, now it's visible.
No, I can't see your screen. Once it's visible, I will just let you know, but it's not visible. Not visible.
Ma'am, I will rejoin again. Please wait.
Fine. Himanshu and Prashant, you can raise down your hands. Not visible, Pawan. So you can ask any of your team members to present. You can just share the document.
Okay, ma'am.
Guys, just make it fast. We don't have enough time to just go ahead. There is a time limit, right? You have to maintain that. Yeah, Pawan, your screen was visible.
Ma'am, is it visible now?
Not now,
Hello?
but back then it was visible.
Okay, okay.
Yeah, now it's visible.
Yeah. Sorry. Sorry, ma'am, it was went off.
You share once and just wait for some time.
Okay, okay. Ma'am,
Yeah,
it's okay
now
now?
it is visible. Yes, it
Okay.
is visible now.
So, ma'am,
Yeah,
I'm P.
you
Pawan
can
Kumar.
start off.
Yeah, yeah, I'm going to
Okay.
start now. Yeah, I'm P. Pawan Kumar. I'm going to present the National Health Insurance Claim Project. So, I'm giving a small introduction on it. The insurance claim dataset provide detailed information about the policyholders and claim outcomes. So it is designed to analyze and predict the insurance claim approvals and detect patterns and identify potential frauds. So using this SQL, we can efficiently store, query, and aggregate this data to extract meaningful insights. This dataset serves as a practical example for applying database management, reporting, and analytical techniques in the insurance domain. So by leveraging SQL operations like filtering, grouping, and joining, we can gain a deeper understanding of customer behavior and trends. So firstly, I started the data preparation part. In that first, I have created the insurance claims table. So firstly, I created the database, which is the week 6 project. In that, I have created some of the tables like insurance claims and the patient details and region. Like this, added the columns in insurance tables like patient ID, age, BMI, smoker, like that. After that, I have imported the data of CSV file by using the import and export option. After that, I got the after that, I'm going to display my tables. Here is the table of the insurance claim data set. In that there are 1,338 rows, and coming to the columns, there are 11 columns in it. So I'm going to describe my table by running this code. We can see that this is the schema of the table, and it contains the details of the data type and is nullable the column default values. After that, I created the patient details. In that, I have I inserted the columns like patient ID, full name. After that, similarly, like insurance claims, I have imported the data of the patient details using the CSV column. After that, after that, I'm going to describe the table of the patient details. Here we see that this is the scheme of the table. And coming to the rows, there are same likewise 1,338 rows. After that, I have created the regions table. In that we see that there are two columns, region and the region code. Region contains the uh, uh, region contains northeast like values, and the code indicates the primary key of the region values. After that, I create this is the scheme of the region table, a region code and the region. Uh, After that, I started the combining of these three tables. I uses the joins to combine tables. I use the inner join. Inner join was performed between the insurance claims and the patient details, and the left join was performed to include the region names from the region table using the region code. So this ensures all records from the insurance and patient details are kept even if the region code is missing. After that, after joining that, I have created the table NIHC to store all the three tables. Here we see that all the three tables are displayed here by using the join function. After that, I have it. After that, I have created the outbound paid column. I use the alter function to add the column. In that, I have used the bill amount minus the claim amount. Here is the default table contains the values like a claimed amount and the uh, bill amount. The bill amount indicates that the hospital charges, and the claimed amount indicates the insurance they got from their paid insurance like premium or any other insurance packages. Here we got the insurance paid amount. It was deducted from the bill amount minus the claim amount. So after that, I created the another column to check the duration between the insurance claimed date and the insurance applied date. Here we see that these are the duration days, 362 to 54. These are the days. So after that, I started.
What happened? You have just
Wait, the network issues. So after that, I have started that data quality checks and the cleaning part. I use the to check the null values. I use the count star and the filter functions to get the all the null values of it. By running this, we see that there are no null values in all the columns. After that, I started checking for the duplicate values using the row number function and the over partition by. Here we see that there are no columns which has a rank greater than 1 indicates the duplicate columns. After that, I use so by using this code, we can remove all the duplicate values. After that, I started the trimming part to remove all the white spaces, and using this code, we can remove all the special characters in the full name and the region to avoid the data cleaning part, for the visualization part and the modeling part. After that, a new column is added. Column is added. It is a year billing, which is an integer. It was extracted from the insurance applied date. So this prepares the data for the time series analysis. After that, I started the data analysis part in the SQL. Firstly, I extracted the insurance start date and the let me sorry. It indicates the start year in which the first insurance first application of the insurance date, and the claim end year indicates the last application of the insurance. After that, I would After that, I have done the reason-wise claimed percentage. Here is the code of it. By running this, we can see that they contains the five columns. The first column is the total leads, indicates the total number of applications which are applied on reason wise. In that claimed count indicates the how many of the policy members got the insurance applied on the all count. Here we see that there are total of 325 applications. In that 183 are applied, 183 are claimed, and 142 are not claimed in the northwest region. Uh, After that, I have done the percentages based on the regions. Here we see that 56% of the claims are claimed, and 43% are not claimed. So after that, I have done the analysis part between the smoker and the BMI. The BMI indicates the body mass index. We have so I divided into four categories, which is the normal, obese, overweight, and the underweight. The normal weight indicates that the BMI's value between the 18.5 and the 24.9, which is the normal, and the underweight comes below the BMI of 18.5, and the overweight indicates the overweight indicates 25 and 29.9. This is overweight, and else is obese, which is greater than 30. Here we uh, here I use the group function to categorize all the values. So here is the detailed report of it. After that, I have stored my all the tables and exported into the NHC CSV file. Here I use the code to export my all my data into the CSV file. This is my part of the project, ma'am.
Okay, so next part will be continued by your team members. So ask your
Yeah.
team members to present accordingly.
Okay, ma'am.
Just go accordingly. Like who have the part next, just present their screen and start off. Yeah, Kavya, your screen is visible, but you are muted.
No, ma'am, Rohit will be presenting now.
Okay. So guys, just make sure, just add the person name who wants to present. After you are done, just add the person name that he will be presenting henceforth. Like that.
Am I audible?
Your voice
Hello?
is not, yeah, Rohit, your voice is not properly audible.
I'm traveling from college to home. That's why maybe
Okay, but how you'll be presenting like that?
I'm like, yeah, is it okay? Like, is it too noisy or is it okay? Like, can I continue?
Yeah, now it's fine. You can continue.
Okay, ma'am. So here I have taken the file which Pawan has cleaned and have shared with me, and I have converted the file into CSV, and I have taken it into the Python, and I have hello, am I audible?
Yes, audible.
Yes, ma'am. So I have displayed the first to check if the dataset which I have loaded is correctly taken environment or not. I have taken and I have displayed it using the hash, and then I have described the data, and I have used the easnal and some functions to check. Can you scroll a bit down, Kavya? So this is the output which I have taken. Like here I have displayed the type of the data and the columns and the count of the patient ID and the total number of full names and the age, and also I have used it over here and I have displayed it. Scroll a bit down. So I have checked the up. So I have here checked the missing values. If there is any missing value, so here we can see that there is no missing value present over here. Can you go down? So here, so I have handled with the data types to check the data type of the columns. So I have used here data to date time. I have converted the data into date time format, and then I have taken the information here. I have displayed the information over here, and there are 7 columns, and there are non-none values and the data type present over here. And for the distributions analyzation, I have imported matplotlib, pilot, and Seaborn and Pandas. I have used these 3 libraries, and using that, I have created histogram. I have plotted the different types of graphs here. Scroll a bit down. So so I have displayed the graphs, the histograms for each and every column. Here we can see for patient ID and for age, and for the region code, for the BMI. Can you go a big slide towards the right? Amount paid, and then here I have showed up the graph for the duration, insurance apply date, and all. So here are the different the histograms for the different columns, and then there comes the distribution of regional distribution of the region. Here I have distributed it based on the region, and here are the distribution of sex and distribution of smoker, like how many claimers are smokers or not, and then the distribution of insurance claim, how many people have taken the insurance and how many people have not taken it. And after that, I have explored the relationships. Using the same libraries, I have plotted the graphs once again for the better data collection and for the better visualization of the data. I have plotted. Can you go a bit down to show the graph? So here we can see that there are the outliers and there is scatter plot, and here it is the heat map distribution of the different columns and the different data according to the numerical variables like numerical data which we have taken in the chart. And now here it is the scatter plot which I have used for the better understanding of the crowded data where the most number of data is being present over there. And I have identified different outliers here for the, can you show the fifth one? So here are the different outliers one. I have handled the outliers for the a bit down. I have identified them using the functions and using the plot. I have used the different plots over here. So here we can see that the bill amount outlier. So the bill which mostly insurance claimers have used is between 10,000 to 20,000, and the 40,000 to 60,000 are just scattered like the outliers. And I have like taken different plots over here for the better understanding using the histograms, using the scatter plots, and using the outliers so that the data can be uh, got understood by the uh, person who is doing the next modeling part for the better understanding and for the better development of the project ahead. Hello, audible?
Yes, audible.
Hello.
Yeah, you are audible, Rohit.
Yes, sir. And so the key findings which I have got is that the data is being very well cleansed, and the data is very accurate to go ahead with the EDA process done by my teammate earlier, and the strong and the positive thing is that the claimers, like the insurance claim which is being taken by the smokers. That means the insurance claim is basically due to the smoking thing. So we can understand that in, that the maximum hospital bill which is applied is basically taken based on the diseases which are caused by the smoking, and for the other related disease. And and we can analyze from the data that the smokers who are claiming are the highest, the mostly the customers of data, like where we have taken the data. The smokers are the consumers which are higher in number, and the engines which are being treated and which takes a lot of money, and it needs to be taken under consideration based on the smoking related disease, and to take the necessary steps for the ahead. So, due to this, so using this, we can check whether the next teammate of mine, Kavya, has taken the insights from my procedures and from the data which I have extracted and which I have analyzed for the modeling process.
Yes, Rohit. Thank you.
Yes.
Hello, ma'am. Am I audible?
Yes, Kavya, audible.
Following the work done by my
Approved.
teammates, both Pavan and Rohit, as part of our team, my main contribution involves transforming raw insurance claim data using feature engineering, building and evaluating predictive models, and deploying our solution for practical use. Then comes the feature engineering part. Let me start with feature engineering, which lays the foundation for high quality model development. First comes the data cleaning part. I handled missing values, corrected column names, and converted dates to proper formats for further processing. I properly handled date conversion for accurate temporal calculations by using to underscore date time function. And I handled missing values by dropping them uh, using drop in a function, which is fine if few are present here. Like next one is categorical encoding. I encoded categorical variables such as sex, region, smoker status into numeric form using level encoder, ensuring our models could interpret these inputs. Next, derived features. To better describe claim behavior, I created new feature like claim delay. The number of days between that is application and claim, which provide valuable context for fraud prediction. The new feature claim delay based on the date difference, which adds modeling value. Next comes the scaling and outlier treatment. All major numeric fields were standardized, and I removed outliers using statistical methods to prevent skewing the training process. I detected and treated outliers on key uh, with z-score filtering on key numerical columns. I dropped irrelevant columns that do not contribute to modeling. such as here patient ID, full name, region code, insurance apply date. All these are like not contributing much to the modeling. I scaled numerical features by uh, using standard scalar for better model training. Finally, I separated the input features X, that is by dropping only the insurance claim column, that is the actual output column from the original data set, and Y, that is target variable, by only considering the target column. Next, column name check and cleanup. For example, I have for that I have first I have displayed all the columns from my data set. That is age, children, sex, region, BMI, smoker, bill amount. These are the columns, that features of the data set. Next, I have used strip str.strip function to like if a column is named insurance column with spaces before or after the column name, uh, str.strip function will clean it to insurance claim, that removing these spaces for a better modeling purpose. Next comes the model training part. The next major step was to build and compare multiple machine learning models to identify the most effective one. I split the preprocessed data set into training and testing subsets with 80 to 20 using train test split. That is 80% of the entire data set is split in as training part, and the 20 part remaining 20 part to test part. Next, for the model selection, initialized three classic classification models. That is uh, random forest, XGBoost, and logistic regression with appropriate hyperparameters. And trained each model on training data and generated predictions on the test set. Next, performance metrics. Each model was evaluated on accuracy, precision, recall, F1 score, using a train test split, ensuring fairness and transparency in our comparisons to compare effectiveness. Better model choice. I selected the best performance model based on the using this max function, that is based on F1 score to balance false positives and negatives in fraud detection. That is striking a balance between identifying fraudulent and legitimate claims. Next comes the uh, probability score and data export. This like probability score and for dashboard and further analysis, augmented the full data set with uh, fraud probability scores predicted by model and exported it as a, CSV file, that is insurance fraud probability full data set uh, in the form of CSV, and shared this comprehensive CSV including all features like actual claim outcomes and our model fraud probability scores. Next comes the deploying part. uh, for deployment, I've used Streamlit. Making sure our solution usable was the final step. So I focused on deployment and user interaction. This is the for the deployment. This is the code for used by the Streamlit uh, uh, for deploying the model. This is the model. I have saved it under the name Streamlit underscore app.py. This I have run using command
Kavya,
prompt.
that is not showing up. I can't see that part of the code.
Ma'am, is it visible now? The Jupyter notebook.
No, I can. Jupyter Notebook is visible, but here it has been seen with the last part saved to CSV, but the Streamlit part where it is.
In this notepad, isn't it visible, ma'am? This notepad.
I can I can only see result full to CSV insurance fraud probe full.csv. That up to that I can see, but where is the Streamlit code written?
In Notepad, I have written it, ma'am.
No, no, Notepad is not visible.
Shall I copy the full code here in the Jupyter notebook, ma'am? Like I have,
Okay,
yes, ma'am.
you have only shared one tab, I guess. That's why it is only showing the Jupyter. If you share the entire screen, then you can share the notebook as well.
Okay, ma'am. 1 second. Your notebook is like Notepad is not visible.
You share the entire screen.
Okay, ma'am. Now,
Just it is visible. The notepad is visible.
yes, ma'am. Uh,
So
for
you
the,
have like why you have written down in notepad? Like the I just want to check about the Streamlit code. Where you have written the Streamlit code?
this I have written in Notepad itself, ma'am. I've saved it under the name Streamlit, and then for
Okay,
deployment, I used command prompt, ma'am.
fine, got it. Okay.
Yes, ma'am. I exported the chosen model and scalar objects to a final model in the form of using this fi final underscore mod this one and this one. Exported the chosen model, that is a random forest classifier and scalar objects to final underscore model dot pkl file using Python's pickle module, making them easily reusable for prediction in a real world scenarios. And for the interactive app, I've used Streamlit. This is the code for Streamlit app. This I have saved with this name, and I'm going to command prompt. And here I'm trying to deploy deploy my model using run statement here. Streamlit run with the name Streamlit underscore app dot py. This will be directing me to the browser section of my system, ma'am.
Okay. Open the browser then.
Yes, ma'am. Yes, ma'am. This is the model, ma'am. In it allows users to input claim details and instantly receive fraud risk predictions. For example, the model I got the data set I got at the end of this notebook, that is insurance underscore fraud underscore prob underscore full dot csv. Uh, uh, and the one that I got from the first phase of our project by Pawan, that is NHIC underscore data. I'm just trying to make understand that how our model works by taking any of the rows as input data. I have chosen the first row. Uh, like I'm entering the values here. First row, the value is like it. The user can enter any values just to make sure that the model is working properly. I'm using the data from the data set itself. Here the BMI. Next, the coming to the bill amount. I have entered all the values from the first row of this dataset. And when I click on predict, it is giving the prediction as it is a legitimate claim, and fraud probability is 0.00. That is, we can confirm this by uh, checking the final data set that we got in our model, that is insurance fraud .csv. Here we can see the active claim, actual claim is 0, which is legitimate for our model.
Okay, Kavya, just change the data. Like, don't have to take
Okay, ma'am.
down from the data set. Like, anything you can put in and just check it out.
I'm entering the values like randomly, ma'am.
Yeah, yeah.
It is giving legitimate claim with a different probability score, different fraud probability
Yeah.
score. Yes, ma'am. This is how the
Okay,
model
fine.
works. Yes, ma'am.
And
Next,
so for you, which model worked better? Which model you have saved actually?
yes, ma'am. For that, I have noted all the results of 3 models in this table. For the random forest and XGBoost logistic regression, all 4 features like accuracy, precision, recall, F1 score. I've compared all of them, and I've asked
Okay.
the model itself to decide which is performing well, like using the max of results here, and it has based on the F1 score, it has chosen random forest model, ma'am.
Okay, fine. So have you just cross-checked is your model overfitted or not? Because for random forest and logistic regression, both you have got around 100% of accuracy, precision, recall, F1 score. So have you checked is your model overfitted or not?
The model didn't overfit, ma'am. I have checked with a few more examples from the dataset that we have used for the model training, ma'am.
So that is not for the training. You have to check for from outside data. Maybe the any of the data from the test section you have to check, not from the trained section. Trained section, that data to you have already given to the model. The model has learned
Yes,
from
ma'am.
that
Yes, ma'am. Yes, ma'am.
only.
I understand. I understand. Like randomly, I've given few examples, and the model is giving like predicting a bit properly only, ma'am. That
Okay,
way,
Kavya, fine.
yes, ma'am.
So, okay,
Yes, ma'am.
fine. So just go
Continuing
down for the next section.
next. Yes, ma'am. I have now handed off the cleaned engineered data trained models and ready to use prediction app to my teammates, that is to Geetanjali. This enables team to create interactive dashboards and professional project reports, ma'am. Coming to the final summary. In summary, this process ensures the data is transformed for insight, models, and fairly evaluated, and our solution is accessible, forming the backbone of our group's insurance fraud detection system. Uh, Next, our teammate Geetanjali will be continuing. Hello, Geetanjali.
It's visible.
My screen is visible.
Yes, Gitanjali, your screen is visible. Gitanjali, you are on mute. You have to with the presentation.
Okay, ma'am. So my name is Gitanjali and I did a dashboard part. So here is a clean data set that cleaned by my team members. So, so the objective of this project was to transform raw data, claims data into a professional interactive dashboard to give executive clear insight into financial performance, fraud risks, exposure, and operational efficiency. So here is a data set that age, children, sex, reason name, reason, BMI, smoker, bill amount, claimed amount, and amount paid, duration, year billing, claim delay, and fraud probability, actually claim. And so here is all the columns. Now move to the pivot table part. So I created the 5 pivot table. First is a row label. That's a annual cost rate, sum of bill amount, and next is a regional delay. That's the average of duration, and third is a fraud risk profile, that average of fraud probability, and third is the average of duration, average of bill payment, that duration caused by reason. And the fifth is a risk reason, that I use fraud probability and average of fraud probability. And I use a slicer. These two slicer are connected with these 3 pivot table, and these two slicer connect with these 2 pivot table. So here is a first dashboard part, that is a insurance claims executive summary, executive and cost summary trends. So first I created a KPIs. This is a total billed amount. This is a sum of bill amount overall total. This is a magnitude of the portfolio. It quantifies the total expenditure the company is exposed to. Every dollar saved for lost is a function of this total. And second is the average claim delay. This is the average of duration, single number from average delay. This is the operational health indicator, 197 days. This number is a clear indicator that occur average claim processing time exceed at a standard 6-month 180 days service goal. We must use the delay step to find out where the failure is occurring. And third is a high risk claim count, in which I filter fraud probability greater than 0.85. from risk count pivot table. This is a critical risk exposure. This number represent the volume of claim flagged by our model as being flagged by our model has been highly likely to be fraudulent. This is the highest priority for our investigation team. Okay, the role of the slicer, interactive filters for reason name and smoker. Exfoliation, the slicer are the primary executive tool. By clicking one reason, the executive can immediately see. So when I click northwest, so the line chart is changed. When I click 0, so there the y-axis become the 0, and when I click 1, so it's also changed. So the executive summary is designed as the control panel. The answer of 3 questions instantly: how much is it costing us, how slow are we, and how much risks we are facing. So the line chart plots sum of bill amount, and over the year, there is a 2018, 2019, and 2023. It is a based on cost and pivot table. The chart provide our financial baseline. We observe that annual costs have remained relatively stable across the portfolio with no dramatic spikes or drops. Actionable takeaway: currently managing a predictable financial risk. The key is to use the slicer to ensure the stability holds, even when filtered by high risk factors like smoker or specific reasons. It is the line spikes when filtering for smoker, then a single to focus on investigation. Now move to the next, fraud and risk insights. So here is the tab uses predictive analytic to identify and quantity risks. So first is a fraud risk by smoker status bar chart. So when I click the 1, so it show the yes, it's smoker. When I click 0, so it shows a uh, zeros level smoker. So on rows is the average fraud probability, and the values to compare the risk profile of smoker versus non-smoker. The 1 is a smoker and the 0 is a non-smoker claims. Next is the regional contribution to high risk claims. This is a bar chart. Rows in a reason name, values average of fraud probability, filter manual selection of high probability score greater than 0.85. So here is all the values are greater than 0.85 to identify which reason contribute the most to the high risk average. When I click northwest, so it's changed. So the northwest prediction is show. Key insight found: smoker risk exposure claims from smokers show an average fraud probability significantly higher than non-smoker, confirming this is the primary risk factor. And regional risks hotspot: the high risk by region chart reveals specific region, example northeast or northwest, where the average probability of high risk claim is highest, suggestion where investigation resource should be concentrated. And then now move to the delay operation. Sure.
What happened, Gitanjali?
Just wait, ma'am. I don't know. I don't know, ma'am, why it's not working. Okay, so this is a delay operation performance, regional processing efficiency, duration versus cost. This is a final tab, analyze efficiency and justify processing times. So this is a relational efficiency combo chart using pivot table duration cost by region. The rows is a region names, average of duration, and columns is average of bill amount and line secondary access. So business purpose to test if long delays are justified by high cost claims or are due to inefficiency. Key insight: efficiency versus complexity. This chart is a critical for management scenario one, high column plus high line. So this is a high columns and high line. If a region has a high duration column and a high average coastline, the delay like due to claim complexity, which is often acceptable. Scenario 2, high column plus low line. If a region has a duration column but a low average coastline, these flag a critically operational bottleneck that need immediately investigation as a simple claims are being proceed to slow. When I click the northwest, so it shows the north website claim. North. So the summary: financial stability, cost trends, and risk mitigation, smoker reason treating for fraud and process improvement, identify regional processing failures. The immediate action is to finalize a smoker claim review policy and task the operation manager that investigation the reason flagged by the high column plus low line pattern on the combo chart. Yes, ma'am, it's done.
Okay, fine. Then just go ahead with the PPT and the report that you have prepared.
Okay, ma'am. So the PPT report is present by Bhavni.
Okay. Gitanjali, you can stop sharing your screen.
Okay. Actually, ma'am, I will
Yeah.
share the screen for
Okay,
report
fine.
and
Go ahead.
presentation.
Okay, okay.
So, Bhavni, please start.
Good evening, everyone. I myself is Bhavani L. Today I'm going to explain about the National Health Insurance Claim Analysis. So, so the so the project introduction first. So our project name is National Health Insurance Claim Analysis. What is the objective of this project? Why we chosen this? So the data management cleaning and in-depth of analysis, health insurance is very much important, and we done in a SQL part and trends, risk factors and identifications of this project. So we selected a data source, um, NIHC.csv, from the span of 2018 to 2023. Scroll it, Gitanjali. Gitanjali, are you there? Yeah, the datasets components, it's mainly involved, we utilize the three initials normalized tables as insurance claims and patient details and also the region. So the main key factors of this data, health factors, for the health factors, smoker, BMI, and age, and like in a financials part, bill amount, claimed amount, insurance, and also the regions. So comes to the SQL part. Here, as a Pawan said, the in data integrations, he used the SQL means structured query language. Um, the table was made for the insurance claims, patient details, and also patient ID. Here the move further, Gitanjali, for coding part, SQL code. Here Hasi said about taking a patient and his patient ID, patient full name, age, and children, and his gender, region code. With respect to he take a full patient history, his details, and data cleaning in the data cleaning and transformation part. So it checks for a null or any duplications in the code itself. It will detect using the code of filter, and it will detect with a zero nulls and zero duplicates in the final structure. So as a text cleaning, it's removed all extra spaces and extraneous characters in a smalls and caps characters will removed. Next, feature engineering. So here, in the feature engineering, it will analysis the like in a column wise, and it will measure the financial impact in a processes. So as he said that in the main part of the insurance, like amount and duration, how much duration is they may take to claim the insurance, so how much amount is will be paid. So for that calculations, that amount paid will be bill amount minus claimed amount, and also the duration, like that how he applied for this, in the which date, and when it's insurance when it's claimed, by the duration calculations. After that, we check about the smoker and BMI. So BMI means body mass index. So as per this analysis, BMI categories were there, of normal, overweight, obese, underweight, grouping these data with the smoker. For example, if as Gitanjali said, if click 1, the smoker will appear, and click 0, non-smoker level will be shown. Then fraud detection and streamlit part of Kavya and Rohit. So this will go into that fraud detection modeling. So here use the IPOMB Jupyter file for using machine learning or statistical modeling for this. So what the pipeline? So this is the major part of it. So here we feature for our feature selections. He used for a haze, smoker, bill, bill amount, etc. From the data sets. So for a model training, scroll it. Chapter 2. Chapter 2. Yeah. So this is the EDA part. Um, so for fraud detection model here, in representation of machine learning or statistical model, but the pipelines were using for a feature selections, a smoker bill amount from the NHIC data sets. So here for model training for classification of a fraud, if fraud or not. So and check the model evaluation for the model metrics for a purpose like check the insurance and advanced analytics for it will help. Then Streamlit part. So Streamlit app is for it's the Python file. So it creates web applications and s- Gitanjali, scroll it. Image part. Uh, so this is a Kavya part, insurance fraud detection, Streamlit app. So as she said, we click the age and given different data sets to check the data to check the data with the claims and also the range. So after the BMI analysis and also see simulation tools, the final part is dashboard. So here dashboard part, that executive summary and successive rate, cost trends, fraud detections rate and risk. Gitanjali, go to chapter 4. Yeah. So in the dashboard part is done in the Excel. So the data points were clear, visuals, and also formally means well structured, clean data with the dashboards. So here executive the dashboard's first part is an executive summary. So here the what are the key metrics? So there was total bills, total claimed amount, claim success rate. So here claim success rate is 60.77 overall percentage with after calculations with a success rate and cost rates. So this claimed by the region by the percentage with the northwest and southwest. So for the northwest is a say 67.31 percentage, and with the southwest is lags with the 50.15 percentage, and fraud rate and risk. Here value was here's that insurance claim with a percentage with the BMI and divided by smokers segment. So here obese smoker is is observed as 100% means he checked this and he get claimed, and normal like a non-smoker he get a 0.00. There is a no risk means lowest risk. And regional process efficiency part. So here that region part Here, the average of the data means the average insurance claim durations in with respect to days, and in which day he claimed for means he applied for an insurance, and which day or it take my month to claim the insurance for the durations it will shows, and shows which like regions lowest and fastest claims, highlighting the operations. Thank you, ma'am.
Okay, just go ahead with the PPT section. So who is going to explain the PPT part?
Ma'am Bhavni.
Okay, fine. Bhavni, just keep it simple. Don't have to exaggerate. Just since major parts already been discussed, you have to just go to each of the slide and explain a bit. Don't stretch it much. Okay.
Yeah, okay, ma'am. Yeah, just summarize the whole project. Here, the first slide, data, data management and key insights from SQL analysis. So the data were set, data consolidation and preparations. The initial step we take and creating the three tables and with the insurance claim, patient details and regions, and taking the SQL analysis and doing this, and with the SQL joins or like inner joins, left joins, and also data cleaning parts with the announcement. In data cleaning part, data integrity checks confirm that its absence of a null values and also duplicates. There is a there is enhanced with by removing the special characters and spaces, and the amount paid durations year with the billing excited extracted from the application date, and durations with the time days between the applying and the claiming in by the insurance, and the amount paid, bill amount, claimed amount. So the key findings, it's from the span of 2018 to 2023. Can you just go to slide 3? Slide 3. So the data cleaning part and enhancement part are already done. So from the data is collected from the span of 2018 to 2023. The analysis is centered from the claims with the success rate and across the demographics, health, geographic, and segments. So here, regional performance and move the slides. So we are going to deep and dive the SQL and patient data and claim strains. So here already I told about this. With respect to the cleaning data, remove the duplicates and transforming with the data sets, master the tables and calculate the amount and duration of it for claiming the insurance, and analyzing the part using a BMI, means body mass index calculator. So after that, how much this is a calculation part of amount paid equals to bill amount minus claimed amount. Next slide. Next slide. So this is the highest success rate, as I already said, that northwest and southwest. uh, From the north side is a 67% something, and southwest is a 51.17 percentage. So this highest and highest we can see from the southwest after the calculations of a BMI category with respect to the smoker status. Mm, and we can see the obese smokers, they get insurance claims with 100% surety, and overweight smokers will get lesser than the obese smokers, and normal BMI. So they are non-smokers. Definitely is 0.00 claimed. So next slide. So this is our data-driven insights on our regional health and also financial claims trends. As I said, the 2018 to 2023. So this is all done with respect to the SQL part and also fraud detection model with respect to take the patient data and visual impacts. Next slide. So we can see from the all dashboards and the overall project. Mm, So the result will provide the insurance stakeholders with the clear data-driven evidence for all refining this data with the policies and improve the insurance claims process with the efficiently and better management progress. Thank you, ma'am.
Okay, guys, you can just stop sharing your screen. Now, I'll just call each one of your name from the group, and you have to just show me your the that all the mini projects has been shared by you in the mail. Just open your mail section, everyone. I'll just call out each one of your name. You just need to show me. Fine? Is that clear, guys?
Yes, ma'am.
Fine. Share your screen. Bhavani, can you just share your screen? Bhavani, can you respond actually?
Ma'am, I didn't share the projects in mail. I just make a link of them. Means in
No,
I sent
you
it in the
have
group.
to. Fine, got it. Who have not done,
Can I
please do
share?
it.
Ma'am?
You do it. If you have not shared the projects in the mail, then you have to share the projects in the mail. Also, with your GitHub repository link, like all the projects has to be uploaded in the GitHub, and that link you have to share in the mail. Along with that, since you like how many you have gone ahead and like presented in the session, Bhavani?
Ma'am, I presented all
You have presented all in the session.
except that one that project 3, I think.
Okay, so just confirm me and
But
tell
I
me
did. But
how many you
ma'am,
have presented in the session and how many you have a video presentation of.
Yes, ma'am. Wait, ma'am.
Pavani, you just cross check and tell me. Fine. By the time I am just going to other people.
Okay.
So, Gitanjali, you're here.
Yes, ma'am.
So, can you just share the screen?
Yes, ma'am. It's visible, ma'am.
Yes, it is visible. Just go down to the mail section. Okay, it's week 4, week 5. Just open it down for week 4. Open the one. Okay, week 4. Go to the mail section for week 4. Yes. So week 4 and week 5, that's fine. Where are the other ones? Like for 1, 2, 3, third, first week, second week, third week. Gitanjali, you can switch on your mic, no? Because I can't hear you.
Yes, ma'am. For week 1,
Uh,
2, 3, I submitted the Google form.
no, you have to submit in the mail. Last week also I confirm you, right? You have if you have
No.
submitted in the form, then also you have to submit in the here in the mail. You have to submit it,
Okay,
Rahul.
ma'am. Okay, ma'am. On today, I will submit it.
Fine. So just join
Yeah.
up tomorrow and confirm me because I need to see it. Just
Okay,
open
ma'am. Sure.
week 4 video. I just need to see how you have prepared week 4, week 5 video.
So here is the
Just
ma'am
play
week
it,
4 video.
play it around. Okay, fine. Like how you have prepared, haven't you used like you have used another device or how you have taken down the video?
Ma'am, for this, I use my mobile phone.
So there is like you have used mobile phone, but there was an explanation, right? Like there
Yes,
is an
ma'am.
audio, right?
No, ma'am. For ma'am, I also explain them.
You have explained them,
Yes, ma'am.
but I already mentioned you, right? Why you have used your mobile phone? You have to use either you have to use either the Zoom Meet or Loom, any of the app. There you have to just screen share and have to go ahead, right? So this is not the proper way of doing a presentation. So you have to use the Zoom app. There you have to present, like just record your screen, present the screen and record the session, keep your camera on and then start explaining. This is not a proper way of recording any of the video, right, Gitanjali? You have to redo it and complete
Okay,
it by tomorrow
sure, ma'am.
because tomorrow is the final day where we will take down the names for the final certification. Okay, so
Okay, ma'am.
whatever the task remaining, you have to do it. Upload
Okay.
all of the projects in your GitHub, share all of your project details in the mail. Along with that, share the videos, proper videos presentation should be there. Okay,
Okay, ma'am.
you,
Sure.
you can use Zoom or Loom app.
Okay, ma'am.
Okay, Gitanjali, stop sharing. Pavan Kumar, you're here. Pavan from group 1, sorry, group 2, you are here. Hey Rohit, you are here.
Yes, ma'am.
So have you shared your projects in the mail along with the video presentation, proper video presentation using Zoom or Loom app?
Ma'am, I have presented in the Zoom meeting, but I have not shared it in the mail. I have shared it in the Google Forms only.
No, guys, make it clear that you have to share your projects in the mail ID. Last day also I have confirmed you. How many time I have to clear you? Those who have not presented in the session, they have to, like every one of you who have presented and not presented in the session, they have to share your projects in the mail ID for sure. Okay. And you have to also share the video, like who have not presented in the session, you have to create a proper video presentation in the Zoom or Loom app where you will be like presenting the screen and recording your session, keeping your cameras on and present it for at least 7 to 8 minutes minimum. That is a minimum time frame that you need to match up. Like 7 to 8 minutes, you have to present your project. Fine, you have to explain your project up in that format. So like that, you have to just after you are done with the video presentation, you have to just upload that video in the Google Drive and you have to share that Google Drive link in the mail. So this is the form that you have to do it. Whoever have not done it, please do it. I am not checking it today. Tomorrow I'll be definitely checking it because without that you will not be getting the certificates. So it is a mandatory task. You need to do it. Okay, make sure that you do it by tomorrow. Tomorrow I'll be checking it at 6:30 or 7. I'll be checking with that. Before that, the presentations will happen. After that, I'll check with each and every one of you. Fine, guys.
Ma'am, can you just tell us like what should we add up in the mail and how it should be like in what format?
Yeah, there would be first week name, like put it like week one project title, then add the link of the GitHub link that you have put it in. The GitHub link should be there. Then the video presentation link, like how I told you how the presentation should be. In that format, you will be recording the video presentation and that link will be there. You have to upload the video in the Google Drive and from there you have to create the like after you when you just upload any video up there, you get an option of sharing the folder or sharing the file in the Google Drive. There you have to share it and just click the option for anyone having the link will get the access to see the access that folder like that. So you just keep it like that, make it like that, and then share the link in the mail for all of the weeks from first to fifth week. Is that clear?
Okay, ma'am.
Okay, make sure that you do it. So today group 2 is done with the presentation, but this part is remaining. Without this, no one will get the final certificate. Fine. So make sure that you complete it by tomorrow. Each one of you from group 2. Fine.
Okay, ma'am.
Okay. So we'll just go ahead with group 4. Before that, just a minute. Svetanshini, you are here.
Yes.
So, guys, are you like, have you had a discussion? Like, will you be able to go ahead with like the dashboard part? Will you be able to prepare the dashboard in a day?
We will try and we'll try to present it tomorrow. Shivani has said that she'll try once.
Great. So you can work accordingly, and tomorrow I'll take down your presentation. And this part that I have already mentioned about the mail sharing and the video presentation, everyone have to do it. So guys, like group 3, just make sure that every member of you who are involved in the project does the same. Okay, Swetanshini?
Yes, ma'am. Ma'am, also we have to present both report and presentation, right?
PPT, yes.
Okay. Both of the
Okay, so
means report as well as the
everything.
presentation.
Yes, yes, yes. Okay. So accordingly, prepare yourself for tomorrow. Tomorrow I'll take down your presentation. Fine. So Group 4, you can present the presentation now.
Excuse me, ma'am.
Yes.
Ma'am, actually, there is a little tragedy occurred in our group. Ma'am, actually,
What happened?
Sudarshanan did predict feature engineering in Python, and rest part
Okay.
he did in SQL. And Jhansi is not available right now. She's traveling, so she won't be able to give presentation. So, ma'am, can we just present our part today or tomorrow?
I didn't get you. Like, what exactly is the issue? Like, Jhansi is traveling. She was traveling before also, right?
Yes, ma'am. And ma'am, Sudarshanan did the partial work in SQL and the remaining part in Python, which was not allowed.
So why you are doing it like that? You are supposed to discuss among yourself and like come prepared for today, right? So why this has happened?
Ma'am, actually, I had clearly informed in the group regarding task allotment and the tools to be used.
So what is the issue now? Like what exactly is the problem now? Jhansi is not available. She won't be able to present the PPT and the presentation, right?
Yes, ma'am.
This is the first part. Second,
And ma'am, Sudarshan did half of his work in SQL. So, ma'am, can he present the both the part or just the SQL part?
like how you have taken down your project. First, tell me that, like who had done what and like how much it's been done and in what format it's been done.
Just a minute, ma'am. So, ma'am, I was doing data cleaning and statistical modeling using Excel. Sneha was doing data collection and visualization using Power BI. Shivani was doing
Okay.
EDA using Excel. Sudarshanan was allotted feature engineering and predictive modeling using SQL. And Jhansi
Mhm.
was allotted to make PPT.
Okay, fine. So you are being doing employment data analysis and skill gap, that one, right?
Yes, ma'am.
Okay, fine. So there you have been allotted with Excel, SQL, and Power BI. So, like, why Python has came up?
I don't know, ma'am.
So haven't you informed Sudarshan and like he was also here, so he should have like have that part in mind. Like you have to take care, like how it is been allocated. You have to use those tools only. So will you be able to fix this by tomorrow?
Sure, ma'am, I will
Moreover,
try.
Jan. Okay, fine. So I want each and every member of your team tomorrow to present the session, to present your project all together. Fine. If anyone is not available, I'll not take down that person's name. Okay,
Okay,
Abhijay.
ma'am.
Fine. I'll just give you
Yes,
time for
ma'am.
today. Just make sure that you clean up everything, whatever be the stuff, and make sure that you people are well organized. Like you should not like after you have done with the presentation, you have to wait to discuss among yourself who next will be presenting. Fine. Just make sure that you complete all of it, all of this mess by tomorrow, and come up prepared with a clean version of it.
Okay, ma'am.
Okay, fine. So we'll just now go ahead with group 7. Himanshu, you're here.
Yes, ma'am.
So
Ma'am,
is
actually, I am facing issue in deployment the model. Can I show it to you tomorrow? Rest of part I show it today.
okay,
Only
fine.
deployment model.
So you have saved your model, you have not done with the deployment section, right?
Yes, ma'am.
Fine, you present your project today. Everyone,
Okay, ma'am.
everything is ready, right? Except the
Y-
deployment part, right?
Yes, ma'am. Yes, ma'am.
So present your project today. After that, do the deployment section and show the deployment section tomorrow.
Okay, ma'am. Just give me a second, ma'am.
Fine.
Is my screen is visible?
Yes, your
Hello.
screen is visible.
Okay, ma'am. So we are going to start with our project overview. So hello everyone. My name is Mansur and I'm the team leader of our project Tax Aviation Detection using Financial Data, and completed under Global Next Consulted India Private Limited. Uh, or basically, our project focus on solving a very serious financial problem, tax aviation. In India and across the world, tax evasion causes a huge loss to government revenue every year. The aim of our project was to use data analysis and machine learning to identify suspicious taxpayer whose financial behavior does not match their declared income. In simple words, we aim to build a complete system that can detect a suspicious taxpayer using data analysis, machine learning, and visualization tool. So let me start by introducing my teammates and exploring each member contribution. So Ravi handled the data cleaning part in SQL. He removed missing, duplicate, and invalid data to make the data set clean and clear. The step was very important because our analysis and model performance completely depend on clear data. Then comes to Deepak. Deepak worked on the SQL data analysis. He wrote SQL queries to find pattern like cities with higher fraud density, professions showing a suspicious active behavior, and people whose spending is higher than their income. Then comes to Mayank. Mayank performed the exploratory data analysis using Python. He visualized the data through graph and heat map to find correlation between income, expenses, bank deposits, and transaction. EDA helped and transaction, where EDA helped us to understand how normal and abnormal taxpayer uh, behave financially. Uh, I personally worked on the machine learning and feature engineering part in Python. Before the EDA, I created several new features that help out model detect fraud more accurately. For example, income discrepancy, this difference between the actual income and reported income, and then expense to income ratio to detect overspeeding behavior. These engineering features give deeper insight into taxpayer behavior and made the data more meaningful for machine learning models. Uh, then I applied three unsupervised learning model, isolation forest, one class SVM, and local outlier factors um, to identify the fraud detection. And finally, Virender developed the Power BI dashboard. His dashboard visually presented our entire analysis showing fraud-prone cities, high-risk occupation, income discrepancy, and distribution, and top taxpayer with suspicious activity. It's help investigator easily to monitor and filter high-risk cases. Uh, Overall, our workflow followed a complete data science pipeline: SQL for cleaning and analysis, Python for features, engineering a model, or Power BI for visualization. So next, Mayank will tell you what the result was, our conclusion and key learning, and what are our recommendation. So Mayank, are you there?
Yeah, yes, bro. Am I audible,
Start.
ma'am?
Yes, audible.
So, in terms of result, we found that the local outliner factor model performed the best with an ROC AUC score of 1.00, showing a strong ability to distinguish between normal and suspicious cases. Through our dashboard, we discovered interesting patterns. For example, retired individuals and homemakers were among the most frequently flagged categories, while business owners and had the highest total undisclosed income. This project taught us not only the technical skills of the SQL, Python, and Power BI, but also the importance of teamwork, communications, and problem solving. We learned that effective tax fraud detection starts with clean data, clear analysis, and interpretable machine learning models. To conclude our project successfully, deliver an end-to-end tax aviation detection system from raw data to a fully functional dashboard that can help financial authorities detect potential fraud efficiently. Uh, from here, our team member Deepak will continue with the SQL part.
Thank you, Mayank. Can you confirm, is my screen visible?
No, not yet. Yeah, now it is visible.
Yes, ma'am. Yeah. Initially, I created a database to insert tables and the data, and I using the database and loaded some CSV file into this database. Later, I selected the table which I imported, and next I'm describing the text. The table shows the values, count, and the data types of the each column in the table. Next, I'm going to select I'm going to check all the columns that presented in the table. So it gives me detail count of the rows. Sorry.
Deepak, your
And
voice is not properly audible. It's breaking sometimes, so it's not possible for me to hear it properly.
is it clear now?
No, not clear. It's breaking very much, so I am unable to understand what exactly you are talking about. So you can just try and rejoin. I'll just wait for you for 2 minutes. Hope that solves the issue.
Sure, ma'am. Thank you.
Ma'am,
Yes.
ma'am, can you explain the video recording part again? Ki how to record our project?
You can go to your you have the Zoom app, right? You go to Zoom app and start a meeting for yourself. Like there is an option to start a meeting. So start a meeting, then you'll be included, like you'll be there in the meeting. Then just go ahead, present your screen, and then click to the option of recording. Okay, then your stage session will start where the meeting, like where your screen is presented and your camera and microphone is on, along with this session is being recorded. Okay, there you get an option of recording in the like the lower section actually. So after you are done with that, just start with your presentation as you just presented. Switch on to the, suppose you are presenting any of the Power BI project, then go down to Power BI, open out your project, explain each of the step properly. Once it's done, uh, just uh, just leave, like stop recording, do the stop recording and leave the meeting. Okay, once that is done, you get an automatic recording or two recordings you get. One is only the audio and another is the audio with the visual. Take down the video with the audio, that part. And once that is done, just you just go ahead and upload that video in the Google Drive of yours. Okay. Once that is done, then you just in any of this keep a folder, and in that folder put that video. Like you can do it as week wise also, week 1, week 2, week 3, in that format. Create folders and just keep those videos on. Okay. Now, just click on share. You get an option that you can share it down with someone, or you can, anyone having the link can access to this video. So just give the permission like that and share that link in the mail. Okay. And the
Okay, ma'am.
video that you'll be preparing, that should be minimum 7 to 8 minutes, not 2-3 minutes video won't be entertained. Okay. Minimum 7 to 8 minutes. You have to explain each of the section properly with proper insights. Like you are showing any of the chart, then you should have to explain the proper insight of that. Okay. Is it clear?
Okay, ma'am.
Okay. Deepak, is it done? Can you just present it?
Yeah, ma'am. Am I clear now?
Yes, yes. Now your voice is clear.
Yeah. Yes, ma'am. Is my screen visible?
No, not yet. Just wait. Yeah, now it is visible.
Yeah. Initially, I created a
Just
database. Yes,
just
ma'am.
start from the beginning only, because in
Yeah.
between you lost the flow also, and I also forgot the stuff that you are explaining. So
Yeah,
just
yeah. No
come from the
problem. I
beginning.
will start from the beginning.
Okay.
Yeah. Initially, I created a database to insert my data, and next I'll inserted my CSV file into this database and selected all the database, all the tables to check. So it gives all the columns, and now checking the column types and also data types, the null values presented in the table. It gives me a clear, it's me clear idea and how the table working. Next, I checking the how many rows is presented in the table, and this gives the count 0 because I run the query before presenting this. So the query gets something mismatch. So the count shows 0, but the actual number is 3675. And next, I'm checking for the null values presented in the table. Actually, the table is a clean data set, but for the second verification, I'm checking again for the null values that are presented in the table, and the value shows 0. Next, SQL safe update 0. This is for the uh, offing the safe mode. Offing safe mode is whenever we try to update or delete the data when there are multiple rows, there's some chances of rows error, rows mismatching or missing rows. So now I'm switching off this safe mode and calculating the null values again, and that shows nothing, and I'm not switching on the safe mode again. So this gives me a clear idea there's no null values presented in the data. And next I'm checking for the um, remaining, checking for the rows that are presented after creating this creating after cleaning the null values, how many null values are presented in the data set, and that's the number is 0. And again I'm switching off the save mode to check how many duplicates, switching off the save mode because I need to change the column data types, and the data types are correct. Once again, I want to re-enter into the this correct data type. So I made this query and set it all the data types into the correct format to for my double verification. And then I'm switching on the safe mode again. Now I'm checking for the duplicate values presenting here in the data. The duplicate count is 127. Sorry for the mistake. The query does not show the answer, and there are 127 duplicate rows presented here. And later, after removing some duplicates, I created a new table with the new data set after cleaning the data. So drop table and time table.
Deepak, your voice is breaking again. You created the
No.
new table, right?
Yeah. I'm created the new table with the new data set after cleaning and delete that the old table which has null values and the duplicates and again I'm checking for the new table. Is there any null values or any duplicates checking? And there is no zero values with the duplicates. So I'm going with this a new table which I have created. Next, with I come to the data analysis part. I I use the data analysis schema. For this, I imported the data from the data after cleaning this part. After cleaning this, I imported this data into the data analysis scheme. I'm checking for the various parameters here. How many fraud cases are uh, presented in the data set and frauds depending upon the occupation and frauds depending upon the high fraud density, which city getting the high fraud cases and which is the low fraud cases, and also reported income versus the income which they are spending much higher. So what the reported income and what the bank deposits are showing, it's clearly show there are some fraud cases presented here, and there are also something uh, spending more than the how much they are spending more than the annual income. This shows the annual income shows the 92,000, but the expenses shows the 1,23,000. This clearly shows that some money they are getting from the uh, by doing some fraud or illegal um, things. No, and what about the foreign account holdings? How many foreign account holdings are there and how many fraud cases are happening through these foreign accounts, and what are the large transactions and with the accounts which are large transactions more than three. So I'm checking whether the account is having more than three with their ID and the city they present, and also I audited some cases. This gives some clear idea about, sorry, clear idea about the fraud rate in audit percentage. And the next thing is the fraud happen by age groups. I s- I created this to check the age groups between the happening for the fraud cases. And the next parameter is the cases that happening by occupation and also what is the fraud rate percentage and which city it is happening the most. This gives a clear idea that Delhi gives the most of the fraud cases and the occupation is self-employed. And the under reporting analysis, this gives some clear idea about the focused on individuals reporting less than 70% of the actual income. And the last is the combined query highlighted high risk profile identification. This gives the bank deposit is greater than the reported income, and also gives the over a large number of transactions and also foreign account ownership. Everything will be seen through this data analysis. And this was done with my part. And next with the EDA and the EDA in Python that going to presented by Mayank. Mayank, over to you. Hello, Mayank.
After me, uh, uh, Deepak, Deepak bro, after me, Mayank will explain the EDA part.
Sorry, I can't hear.
Just unmute, bro. Unmute
Yeah,
yourself. Okay. Thank you. My screen is visible, ma'am.
Yes, it is possible.
Ah, okay, guys. Then comes to our SQL part has done. Data has clean, and we get our clean data. Then comes to our Python part, where first this was all about our project and project name, project type, and contribution team, project summary, and uh, huh, from here. First, I imported the basic libraries like Panda, NumPy, Matplotlib, and Seaborn. Uh, for basic, these are the basic libraries. And then interactive visualization for just like hover, we put the hover effect in all the graphs. That's why we import these libraries. And then for data processing and splitting, we import standard scalar or label encoder from sklearn processing, and train test split cross well score and stratified k-fold from sklearn model selection. And then for machine learning, we imported isolation forest, random forest classification from sklearn.assembly, and then one class svm from sklearn.svm. Uh, Local outliner factors from sklearn.neighbors. And then for evaluation, metrics, and report, we imported these libraries from matrices, these. And for model saving, we import a joblib. And then I print that library is imported successfully. Then comes to the loading part. Here I load the data and printed it. The data is loaded. So here, as you can see, the output data set is loaded. Data then comes to data exploration. First, I find the data shape. Data shape is three. Here's the output data shape: 3,296 rows and 14 column. Then find the total rows. Here 3,296 rows, and then total columns 14 columns. Then column list, uh, which is ID, occupation, age, annual income, reported income, expenses. Around there are 14 columns name. Then comes to data types, which is in integer. There are six integers, and float there are there are six values of float, and then object is 2. Then I printed the first 5 rows, as you can see here. Then the statistical summary of our data, which include the count, mean, standard, mean, and 25%, 50%, 75%, and max. So here are the details of statistical summary. Then I find the I for recheck only. I find the missing value. I find the missing values. This is all 0. Then I also check for duplicate rows. This is also 0. Then category value analysis, city-wide distribution in Bangalore, 436 city count, and in Mumbai 435 city count, and Chennai 433, and so on. Then occupation wise distribution. Then I check occupation wise distribution, where retired are 490, homemakers are 486, and so on. Business owner, so on. Then I check the total memory use in this data. So this is 0.66 MB. Then comes to feature engineering part. Basically, feature engineering is the process of creating new meaningful features from raw data to improve model performance, or it's help the algorithm understand hidden relationship between income, expenses, or taxes, and lifestyle, making fraud or tax evasion easier to detect. Then comes to our first income related features. Here I calculate the income discrepancy, which is basically we show the difference between actual and reported income. And then income discrepancy ratio of income, which shows basically the difference of total income. So the difference of total income. And then comes to expenses income ratio, which compares and express income. High values indicate also indicate overspendings, and savings, leftover money after expenses, and then saving rate, which is percentage of income saved. So basically, these column reveal financial habit and whether reported income matches real spending behavior. Then comes to tax related features. In tax related features, first I calculated the reported tax should be, it's calculated by multiplying the reported income and tax rate percentage divided by 100. And then discrepancy, this is reported tax be subtracted by tax paid. And and then discrepancy ratio, this this percentage gap, showing how much tax might have been avoided. Or basically the main output of this column is to help dataset case where tax paid is suspiciously low. Sorry. Transaction. Then comes to transaction feature. It's measure how frequently a person make large transaction. Consider their age. And then effective tax rate actually paid, calculate the real percentage of income paid as taxed. And in unreported income percentage, measure the portion of income that has not reported to tax authority. uh, and then lifestyle mismatch, it's flag the expense lifestyle mismatch. Basically it's flag if expenses exceed reported income or not, where or if yes, it assign 1, or otherwise it assigns 0. And then is normalized saving score, uh, which uh, which measures saving relate to age. Older individuals usually have higher savings. Then cleaning features of data, which means replace infinite value from missing columns or rows, or fill all missing data with 0 to ensure no zero during model training. And then display the summary of new features. Here, as you can see here, total count, mean, standard mean, and 25% of total data, and 50% of total data, 75% of total data of income discrepancy, and so on. Then we saved our feature engineering data set. As you can see here, my feature engineering data set is saved as csv.file. You can easily download it and check in Excel part. Then comes to ED part. This part is done by Mayank. So Mayank.
Yeah, uh, ma'am, is my screen visible?
Yes, it is visible.
So I'll explain the EDA part. First, target distribution. In this, a pie chart showing how many people are tagged as aviators and non-aviators. This first graph shows the basic distribution of our target variables, the tax aviation flag. We can clearly see that the dataset is imbalanced with the smaller percentage of aviators compared to non-aviators. This imbalance means we'll need to techniques like oversampling or weighted models data to avoid bias. Most taxpayers are non-invaders, eh, and aviators form a small but crucial class of prediction. The next one is fraud by city. Bar chart. It shows a bar chart grouping taxpayers by city and showing how many aviators exist in each. This chart compares how tax aviation is distributed and showing how many aviators exist in each. Uh, how the tax aviation is distributed across different cities. Some cities show higher counts of aviation cases, suggesting possible regional economic differences or data reporting issues. Such insights help target investigations or design city-specific risk models. Certain cities uh, contribute disproportionality of to aviation location and is a meaningful variable. And the third one is fraud by occupation. It shows a bar chart comparing occupations, that is business, salaried, freelancer, and their aviation rates. This chart highlights how different professionals relate to tax aviation. Business owners or self-employed individuals may show higher rates because of income flexibility, while salaried workers show fewer discrepancies. This helps us later in features engineering. We can encode occupation type to reflect risk. And the fourth one is age and fraud distribution. It shows a histogram of taxpayers. Age is possible color coded by aviation flag. This graph shows how age is distributed in our dataset. Most taxpayers fall in the middle age range, around 30 to 50 years. Uh, which is the economically active group. By comparing the color, we can see whether aviation is more common among certain age brackets. And the fifth one is income discrepancy analysis. Uh, it shows a box plot comparing income level for aviators versus non-aviators. This visualization compare income range between the two groups. We see that the aviators generally have higher or more spread out income, while non-aviators have tighter distribution. This indicates that higher income individuals might manipulate reports more aggressively. And the sixth one is correlation heat map. Uh, it shows a heat map with correlation among all numeric variables. Uh, this heat map summarize how numerical variables relate to and each other and dark squares represent strong correlations, so We notice that some features like reported income and tax paid are strongly related, which is expected. However, we must check for multi-collinearity before feeding them to machine learning models. Correlation analysis helps identify redundant variables and strong predictors. The next one is tax discrepancy versus report income. It shows a scatter plot comparing reported versus actual income. In this scatter plot, every point represents one taxpayer. Uh, if everyone was honest, all points would lie along the diagonal line, and where reported equal actual income, but we observed deviations. Points below the diagonal suggested underreporting. Uh, Scatter plot clearly reveals discrepancies between actual and reported incomes. The next one is expand to income ratio analysis. It shows a violin plot showing the distribution of income discrepancy for evaders and non-evaders. This graph helps us to visualize the density and spread of income discrepancies. Aviator shows a wider and heavier tail. Uh, Aviator shows a wider and heavier tail, meaning they often report income far from their true values. Non-aviators have narrow centered distribution around zero discrepancy. So the next one is large transaction analysis. A box plot comparing number of financial transactions for both classes. Uh, Here we compare the number of transactions made by aviators and non-aviators. Aviators tend to perform more or irregular transactions, possibly to hide income. This suggests behavioral data is useful in modeling. The next one is foreign account analysis. It shows a bar plot showing relation between owing a foreign account and being an invader. This bar chart indicates how many aviators have foreign accounts. We observe a higher percentage of a foreign account holder among aviators, which aligns with real-world tax avoidance strategies. Thus, the foreign account flag is strong categorical features. The next one is 3D scatter plot. It shows a 3D scatter plot colored by aviation label. This 3D plot combines annual income tax paid. Uh, This 3D plot combines annual income, tax paid, and reported income. We can visually separate aviators from non-aviators. Aviators often cluster where tax paid is low despite high income. Such clear boundaries confirm that our chosen features have done discriminative power. And the next one is time series like analysis. Uh, it shows a scatter plot showing taxpayer IDs versus discrepancy scores. This plot, this plot highlights individuals with extremely high discrepancy scores. Such taxpayers are clear outlier and should be flagged for manual inspection. EDO like this help us identify anom anomalies even before machine learning. Outlier detection helps flag high-risk individuals early. And the next one is expense versus reported income. It shows a scatter plot showing how the model's aviation probability changes with reported income. This graph connects the model output with income output. We notice that as income increases, the predicted probability of aviation may also rise, confirming model sensitivity to income-related variables. This check helps validate that our model is learning meaningful patterns. Next one is bank deposit versus tax paid. This graph represents the relationship between tax paid and bank deposit. We plotted a line chart using Plotly Express, where the x-axis shows the tax amount and y-axis shows total bank deposit. The data is colored coded, green for non-aviators, red for aviators. And as we can see, honest taxpayer maintain consistent relation between tax paid and deposit. The green line increases steadily. However, for evaders represented in red, the pattern is different. Some individuals have high bank deposit but low tax payment, which indicates possible hidden or uncleared income. This visualization gives us an intuitive way to detect potential tax evasion behavior and provide evidence that can be further analyzed using machine learning models. And the last one is sunburst chart. Uh, the 15 visualization is a sunburst chart, which is a multi-level circular plot. It shows a hierarchical relationship between city, occupation, aviation rate. This powerful visualization helps us see which city occupation combines have the highest risk. For example, business owner in certain cities may have the higher aviation rate than others. Sunburst chart gives multi-dimensional insight, helps policymakers target specific groups more effectively. From here, Himanshu will continue.
Yes, just stop sharing your screen, Mink.
Yeah, done.
My screen is visible, ma'am.
Yes, it is visible.
Okay. Then comes to our model part. So before model, we have to process our data model for further inquiry. So in processing, first step, select feature for anomaly detection. We selected the here, as you can see that uh, we selected the above features like an array called anomaly features, where we selected the income discrepancy or unreported income ratio, tax discrepancy, or expenses income ratio, lifestyle mismatch, effective tax rate paid, transaction intensity, annual income, reported income, and back deposit, and then printed that all the anomaly features where we are going to uh, where we are going to process our model. So comes to handling variables. Uh, we extracted these columns from the data set as our predictors, and our predictors x anomaly and predictors and our target variable y anomaly as the text aviation flag. And then here I print the data set overview. So total sample is 3,296, and there are 10 features, and fraud cases are 259. Then comes to the trains. Sorry. Then comes to the train test or split part, where we split the data set using train test and split with 70% data of 70% data for training and 30% for testing. Uh, then comes to uh, um, uh, 30% for testing. Basically in this the data set is imbalanced, meaning fraud cases are view compared or normal ones. So satisfied sampling maintenance and same classes ratio in both train and test set. For that we perform the split and data set. And then comes to scale features. Uh, In scale features, we use standard scaler to scale our features. Scaling is essential because our model, especially one SVM and LOF, are sensitive to features magnitude. That's why we use scale features of standard scaler. Then here I print the basic information. First, the data split. Print the training set, where training set is 2,307 and 10 columns and 10 rows. Test set is 989 and 10. As I told you that split the data with in this we split the 70 we split the data 70% for training and 30% for testing. Then comes to model part. We models part. We implemented 3 unsupervised anomaly detection model: isolation forest, and one class SVM and local outliner. Basically, each model is trained only for normal data and then tested on the full test set of identify anomalies. So here, first model is isolation forest. So in isolation forest, isolated data point by randomly selection features and split the values. In So basically, n estimators show the number of trees. Max sample will show the how many samples each tree sees, and uh, contamination expected, which show the expected portion of anomalies, where we estimated by using white rain anomean. And the max feature, uh, each tree in max feature 0.8, we provide the value of 0.8, which each tree uses 80% of features randomly. And then random state, we give the value of 42, ensure reproductivity. And then job minus uses all CPU cores. Then fit on normal data only. We train only the normal data point. This shows the we train only normal data point. Uh, Basically, the model learn what a normal taxpayer behavior look like income ratio or deposit, etc. Or then comes to predict. In predict, we use in predict we give 1 to normal or -1 to anomaly, in which in this basically we give the value of data so that we can easily find out the anomaly data. So here's the decision function. Here the decision function give a score where higher equal to more normal and lower equal to more likely to be an anomaly. And then comes to where we convert the level into 0 to normal and 1 to fraud. Then convert the then convert to probabilities, which show the values of our anomalies, and then and uh, and then come to calculate matrices, where we find the accuracy. Accuracy is nothing but overall correctness, and then we find the PCS score all of all predicted fraud, how many were real frauds, and then we find the recall of basically it's for all real frauds, how many were caught, and F1 balance the PCS and recall, and ROC curve measure how well the model separate normal versus fraud across all the model. And then comes to isolation forest result. Here, as you can see that accuracy is 0.9333 and precious 0.5417, recall is 1, and F1 score is 0.7027, and ROC AOC curve is 0.9959. Then so basically, the output of this model is overall 93% correct, and 88% of flag fraud were corrected, and it detected 75% of actual fraud. And then comes to confusing metrics, confusing metrics. I also print the confusing metrics of that model, of this model. So on the right side, on the left side, we have actual normal, and on the upper side, we have predicted normal. So 845 are actual normal. Basically, they are true negative, false positive, and false negative, and true positive. So the predicted fraud are here. 66 and 78 are predicted as fraud, and predicted normal as 845 are normal, and zero fraud, which is false negative. There is zero false negative. So after performing the isolation forest, I print isolation forest completed. Then comes to second model, one class SVM. One class SVM tries to find the smallest region in feature space that contains most normal data. Uh, most normal data. Every or when we have to train, then we have to train the model, where as you can see here, kernel equal to RBF, which map the data into higher dimension for better boundary separation, and gamma equal to scale for control how far the infection of influence of one training sample reaches, and then a new contamination for upper bound of fraction of anomalies, and then fit the normal data as we done in previous model. Is learn the boundary that enclose most normal text pairs, and predict the test set. Basically, it's return 1 for normal or -1 for anomaly. It's giving the value, and then convert our data into binary form. 1 is anomaly and 0 is normal. Then convert the probability, give the anomaly score. This give the anomaly as score, and then calculate the matrices. Then calculate, as you can see here, then calculate the matrices as same as here. Just a second. Doing this. Yeah, here. As you can see that accuracy is 0.90770, and precision is 0.4167, and recall is 0.4487, and F1 score is 0.4321, and ROC AOC curve is 0.8458. And then when it comes to confusion matrix, this shows the 862 are true negative, and 49 are false positive, which comes under the predicted fraud. 35 is true positive, which is also come under the predicted fraud, and 43, which is comes under the false negative, which is predicted as normal. You can see here. Then when our one class SVM is done, then I printed this one class SVM completed. Then comes to local outliner factor. Local outliner factor, basically LOF compare local density, how close a point is to its neighbor. Basically, it's calculate the neighbor's point density. If the point is much less than its neighbor, it's an anomaly. Then we have to train the model, which means n neighbors. Usually, there is value of 20, number of neighbor point considered, and contamination expected anomaly rate, and noblet true, which means allow predicted on new data, and and uh, and job gives the value in negative, and fit on normal data only, uh, which is same as which means the data is fitted in normal value only. And then prediction, then comes to prediction, where it's also predict one is normal and -1 is anomaly, which gives the value. Then convert the binary, one is anomaly and 0 is normal, and -1 for anomaly. Then convert this value into probabilities, so that our density is calculated. Then I calculate the accuracy, precision, recall, F1 score, and ROC score of local outlier factor results, which shows the accuracy of 0.9474 and precision is 0.6000, and recall is 1, and F1 score is 0.7500, and ROC curve score is 1. Then comes to confusion matrix, where it's a local outlier factor confusion matrix, where the 859 are true positive, and 52 are false positive, and 78 are true positive. These two are comes under the predicted fraud, and these two comes under the predicted normal. So 0 is the false negative. Then when I completed the LF part, then I printed it. Then combined the ROC curve. Then combined the ROC curve. Here I calculated the ROC curve model which I calculated earlier. Here just I combined it, all three models, ROC curve calculated. As you can see here, isolated forest AOC curve number is 0.9959. One class SVM uh, number is 0.8458, and local outlier factors is 1. Then I combined all three model to train to detect the and to perform the ROC curve. As you can see here, isolation forest is in red one, and one class SVM is in green. Here, as you can see that all the AUC and TPR values are given, and then comes to blue part isolation forest. So we also we also compare the matrices which are good in model. So here we calculate the basic matrix for all model. So in model, isolation forest, one class, local outliner, and here ROC and AOC curve, and accuracy, presentation, recall, and F1 score. Here all score of all the model, you can see here. And then I selected the best model from each matrices and then print it. In ROC, local outliner factor is best, and accuracy, local outliner factor. In this also local outline factor is best, and precious in this also local outliner factor is best, and in recall isolation forest is best, and in one score local outliner factor is best. So overall best model is ROC. So I saved this model as you can see here in this file, and this file saved here, saving the model. And then deployment model, this don't know, I'm facing some issue in this. Then comes to visualization and general insight, where we were going to display some suspicious transaction using our best model. So here I calculated the performance of LOC performance, ROC or AUC curve 1, and accuracy is 0.9474, precision is 0.600, and recall is 1. And then comes to LFO suspicious transaction, where we calculated all the values related to the uh, top suspicious transaction. Here risk level, here I calculated the risk level, red flag alert, or actual versus predicted, and financial distribution. Financial distribution, I have income discrepancy and unupdated ratio, tax discrepancy, or lifestyle mismatch. So here you can see that I take the top 20s here. I take the top 20 suspicious identities by using LOF model. So as you can see here, LOF score is 1. This shows the high risk. This is in red flag case, immediate attention required. Actual is fraud, and predicted anomaly. Income discrepancy is 6,32,432. Unreported ratio is 0.51. Then tax discrepancy is 71,704, or lifetime mismatch is no. So here we all find the top 20 data of fraud anomalies, and that's it. And the dashboard part is Vrinderjeet will going to. Vrinderjeet, are you there?
Yeah, bro.
Okay.
Himanshu, what issue you are facing related to deployment? Is it related to ngrok, the password key auto encoding part?
No, auto encoding part in server issue, ma'am. Is showing the server issue actually.
So ma'am, my
That
screen
is,
visible.
yeah, Virendrajit. Just a moment, Virendrajit. Yes.
Yeah.
So that might be related to ngrok related stuff. Also, maybe related to the port that you are using. Okay, and
Okay, ma'am.
before you are going ahead with the local host, like either you are using the local or the URL part, you are taking into care, and before that try and do that dot kill function you use, so that the background
Yes,
apps
ma'am.
that are been there, that can be killed, like that can be like shut off, and you can just the Streamlit app can be taken care in the front. Fine. So hopefully
Okay,
by that the issue will be solved.
okay, ma'am.
Yeah. So you can show, if you are deploying it, show me the deployed version tomorrow. Okay?
Okay, ma'am. Okay, ma'am. I will show
Okay.
you tomorrow.
Fine.
Can I start, ma'am?
Yeah, definitely.
So, hello everyone. My name is Vrinderjeet Singh. So I handle the Power BI and the dashboard part. So our project addresses a core failure of our current tax system, inefficient auditing and massive revenue loss due to underreporting. Our data shows that less than 5% of taxpayers have been audited. This means we are blindly missing revenue. So firstly, I import the data, clean data in Power BI, and added some columns that help for visualization. First one is income discrepancy, and the calculation of this is actual income minus reported income. This column is the fundamental measure of problems. magnitude. It calculates the exact monetary gap between a taxpayer truly earned and the figure they officially declare to the authorities. And next column is discrepancy severity. The calculation of this is income discrepancy divided by reported income. This column moves the beyond the absolute dollar amount of measure the oddity or the underreporting. And the next column is ERS, evasion risk score. And this is I created using DEX. The calculation of this a single weighted sum of all suspicious factors, example severity, foreign account, large transactions, and this column contain the various risk score in the engine of dashboard. It is a single continuous numerical value that provides the final combined probability that a taxpayer is engaged. And next one is ERS, percentile rank. The calculation of this is the ERS score translate into a percentage 0% to 100% relative to the population. This column takes the complex numerical ERS and translate it into a native percentage based ranking. It tells the user what percentage of the population a taxpayer is riskier than. And let's move to dashboard. Firstly, this is the alert dashboard. I have created two dashboards. This one is first dashboard, the alert dashboard. Uh, this dashboard contains 7 components like 3 KPIs, 2 slicers, 1 table, and 1 bar chart. The KPIs, firstly, this one count of ID. This is the baseline. It tells you the total size of the population being monitored. This number represents all 3296 individuals in dataset. And then second KPI, total tax. This is the total value of the problem. It represents the cumulative amount of income that the entire population failed to report. And the last one, audit penetration rate. This is the audit penetration rate. It means 4.61% of taxpayer in the system have been audited at least once historically. And then the table part. This list tell the auditor who call first. The individual at the top of the list represent by highest predicted risk and should be the top priority for investigation. As you can see, I showed by descending order. It shows the most top players that have most risk in this dashboard. Then comes slicers. Slicer first is on city. And second slicer on occupation. Then the bar chart. This chart visually ranks the profession based on financial impact. The bar chart at the top shows the occupation that contribute the largest absolute volume to the total system discrepancy. And this is my first dashboard. Now going to second dashboard. Tax fraud risk monitoring. This dashboard contains 3 KPIs, 1 pie chart, 2 bar charts, and 1 line chart. So first KPI shows the total annual income. This is the total theoretical income reported
across the entire population. It established the scale of the economy auditing. Then total system discrepancy. This is the most crucial financial KPI. It represents the total cumulative amount that all taxpayers failed to report. This is the reported income, and this is the annual income. This is the income discrepancy. This is the difference between these two. Then move to pie chart. This chart visually confirms the base rate of confirmed fraud. As you can see, the tiny 7.86% shows the confirmed fraud, and 92.14% is the unconfirmed. Then the evasion rate by occupation bar chart. This shows the evasion rate percentage of people in the tab job who are confirmed evaders. It is guide policy and specialized. And then come total discrepancy by occupation. This shows the focus on sector. The occupation at the top contribute the largest volume of hidden money. Then come to average of income discrepancy by ERS bins. Firstly, I convert the ERS bins into small parts bins. That, as you can see, this is the first 100, then 200, 300. I divided into groups, and this is a core validation chart. It visually proves that a higher ERS directly correlates with a higher average hidden amount. And this is the dashboard. As you can see, in Mumbai, we have total income, this, and reported income and income discrepancy, and then others. And that's all about dashboard.
Okay, fine. So kindly go ahead with the PPT and the report part. Make it brief because your project, like as far as you have explained, everything was way explainable. So you can just make the PPT and the report part a bit shorter.
Okay, ma'am. Screen is visible.
Not, yeah, now it is visible.
Yes, ma'am. So PPT I showed you earlier. We start with PPT only. So here's our PPT. The Our project topic is tax evasion detection using financial data, and these are the team members' names and mentor names and organization. Then comes to SQL data cleaning, where we clean our unclean data. The total financial data is with 3,675. After cleaning, we left with 3,423 clean data. Then SQL data analysis.
Himanshu, you have explained this, so I have no issue with that. But you have explained till the sequel part in the PPT. Later, did you continue in the sequel part, like in the PPT part?
Sorry, ma'am.
Like when you have started off, you have just gone ahead with the some part with the sequel, and then Mayank has taken over. Sorry, Deepak has taken over, right? For the sequel
Yes, ma'am.
section. So
Yes, ma'am.
after that, you can start off with the PPT section. From third slide, yeah, maybe third or fourth slide, I guess you have taken some bit with the sequel, or you have just gone ahead with the some part with like the introduction part with the PPT.
Yes, ma'am. Actually, I introduce all the members and their works directly with
Okay,
PPT.
fine. So then you haven't continued with the PPT, right?
Yes, ma'am. I have to
Okay,
show
fine.
only
Then
report
continue.
part.
I got
Okay,
it.
ma'am.
Fine. Fine.
Yes,
You
ma'am.
just go ahead with some bit of it. Like, don't have to explain thoroughly. Just go a
Okay,
bit
ma'am.
like normally you can go, then you can switch to the report.
Okay, ma'am. So here's our data analysis part, and then comes to Python feature engineering that have performed in Python. And then we have used three model: isolation forest, one class SVM, and local outliner editor for our to finding the fraud detection. And then this is the summary of our model. Isolation forest recall is one around this. Actually, this is 93%, but it's showing one. And then one class SVM accuracy is 90%, and LOF, which is more compatible, is one. And then comes to dashboard overview, where we show the prioritize high-risk taxpayer based on ERS score and enable easy case prioritization for auditors. Then on eighth slide, tax fraud risk monitor, which is second dashboard, visualize income discrepancy by occupation and translation count, and then help the it's basically has help the strategic allocation of audit resources. Then these are the key learns, where the data cleaning is crucial for reliable fraud detection, and SQL powerful for features for extraction and initial insights. Then we use Python for for model and machine learning, or for EDA part, and then dashboard for improved decision by making clarity, or we visualize our whole project. So conclusion and recommendation. So here's a conclusion: clean and integrated solution linking SQL, Python, and visualization. Unserved method suit real-world fraud detection challenges, and unsupervised method. Then dashboard translate complex result into actionable insights. These are the conclusion and recommendations. So directly comes to our report part. So on first page, we have basic detail of our team members and mentor name and duration of internship and company names, project title. And then comes to second page, we have table of content, in which we have 3 pages of introduction, and after that we have company overview, and then project description, and then SQL data preparation and analysis report, then text aviation detection using financial data using Python. These are the introduction about model which I have used in Python. And then analysis text aviation detection dashboard. In dashboard, we all visualize the dashboard part, and then key learning, and then conclusion and recommendation. So here's the introduction, what we have done in project and how we have done, and then it's a company overview, where we have doing our internship, and what are the domains in company, and duration, and the mode, and learning experience, and career impacts in the company. So here's a project description, which uh, provide the all description about our project. And then SQL data preparation of analysis report. Here we show the step-by-step calculation we have performed in SQL. First, we do the data cleaning part, and then when the data cleaning part is done, then we comes to data analysis phase, where we analyze the data to understand unsupervised, uh, where we understand the unauthorized transaction or fraud cases. Then comes to tax evasion detection, financial data using Python. Here we first we uploaded some our data, and visualize our data, and then we perform the uh, feature engineering, and then we perform the EDA part, and then we have data processing for modeling, and then we develop the model, compare all three models, uh, their accuracy, precision, recall, F1 score, and ROC. All these are compared with all threes, and we have also create a different complex matrix of different model, and then we also compare all three models in one with ROC or AUC curve, uh, and where we find the LOC model is best for underived data, and then key findings, and then visualization part where we added some first we added some column to visualize the project more, and then created the first dashboard. In first dashboard, we have total income discrepancy and audit pension rate, or the basically it shows the high risk list. And then comes to second, it shows the tax fraud risk monitoring, where we monitor the risk of all the fraud in all the countries, or in all in state, or in other occupations. Then it's a key learning points. Effective tax fraud detection started through the data cleaning and processing to ensure model accuracy and reliability. So it's a key learning and the conclusion and recommendation of from our project. That's it, ma'am.
Okay, Himanshu. So I just recommend one thing, like
Yes,
in
ma'am.
the report where you have the like the description about the dashboard section, there I'll suggest to add a screenshot of the dashboard that you have prepared on. Okay.
Okay, ma'am. Okay.
Yeah, that would be fine. And guys, I'll just ask you to share all of your mini projects in the mail ID. Okay, and also in your GitHub account. Like after you have just taken it down to the GitHub account, you have to share that link, like the GitHub repository link in the mail. Along with, if possible, you can also share the collab file, but the GitHub repository link must be there. Okay,
Okay.
because I am asking, like, if anybody is doing their if it is Python based project, that is fine, they can share the collab file. If not, if any of the dashboard based project or anything related to Excel, so you can just share it in the GitHub, and that link should be mentioned in the in your mail, and you have to share that mail in the mail ID, and I need to cross check that. So all five of you, please do it by today, and tomorrow make sure that you join by 5, because if the presentation starts, then you have to wait. So if you can join by 5, I'll just take down your details, actually check the details, and then you can leave the session because your presentation is done, right?
Yes, ma'am. Also, I saw the model part also, ma'am. I will display it tomorrow.
Yeah, yeah, the deployment section, right?
Yes, ma'am. Yes, ma'am.
Okay, okay, fine. And make sure once, suppose there isn't like you worked with the Streamlit and you got the URL and you have your like the website working, then just take the screenshots of it. Fine. But there
Okay,
are
ma'am.
many times because there are many times when you start presenting and you want to just click it down and open that URL, it doesn't work sometimes. So you have to
Yes,
prove
ma'am.
on that you have like your like the website is actually working, the app, the .py you'll be working on, right? So that is actually working, and you have that thing on. Okay, and that would be also
Okay, ma'am.
beneficial when you'll just upload it in the GitHub. So you have to upload that like the screenshots of the file. Like you can't just take it down the like about the URL. You can just you have that, but it won't be accessible later, right? Sometime later. So
Yes, ma'am.
you have that screenshot on to showcase the details. Okay.
Okay, ma'am. Okay.
So guys, make sure that you join tomorrow by 5 so that I can take down your details first and you can just leave the session so that you don't have
Okay.
to wait actually. Fine.
Okay.
And please also ask Ravi to join in tomorrow. If he, your presentation section is done, but I need to check down the details of his as well. So make sure that he also shares all his 5 mini projects in the mail ID along with the videos. Like the if anyone has not presented in the session, they have to share the video presentation. So make sure that he also does the same. So that you at least all of your task is done, so that I can recommend that this group is already been done with the presentation. They are like qualified for the certification. Fine.
Yes, ma'am.
Okay, fine. Any query, anyone?
No, ma'am.
Great. So we'll just wrap up our session today, and we'll meet tomorrow, and we can start off with your group to show all of the details. Fine.
Okay, ma'am. Okay, ma'am.
Okay, fine.
Okay,
Thank
ma'am.
you. Bye.
Thank you, ma'am.
Bye, ma'am.
Thank you. Bye.